Okay, we're still in integration by parts, and now we've got what I'm going to call type 3. We're going to be doing integration by parts twice, and then we'll be doing something that I'll call wrap it around. Okay, so here I've got an e and a cosine. This differs from the type 1, which had an x and a cosine, or an x and an e. So you've got options for u and dv, but what I'm going to encourage you to do, if you see this e and cosine or e and sine combination, is that you let the u equal the e guy and the dv equal the trig guy, and then your answer will turn out like mine. Otherwise, you'll get just a different looking answer, and you won't be able to really compare. So let's just stay consistent together. So if I let u equal e to the 2x, I'm taking the derivative, so that's chain rule, so that's times 2 e to the 2x. dv to v, I'm doing La Jolla theorem, so that's 1 over 3 sine of 3x. So I have the original problem, which I'm going to need to carry along, right, is uv minus the integral of v du. Okay, take the time to simplify, and I'm always going to suggest you pull the numbers out in the front. So I pulled the numbers out in the front, and I'm looking at this, and I'm looking at this, and I'm recognizing, hey, that's really similar to what I started with. Here I have an e and a sine, and I started with an e and a cosine. So I'm going to do it again, and I'm going to stay consistent, meaning I'm going to let u equal the e guy again, and so then I get 2 e to the 2x. I'm going to let the dv be the trig guy, sine of 3x, so I get negative 1/3 cosine of 3x. So careful with the negatives and the La Jolla theorem and the chain rule. So let's put it all together. So here's the original problem. Here's the first part of parts that came from the first time we did parts, and then I'm going to have this minus 2/3, and then I'm going to put this big parentheses here, because now I'm going to use this parts of uv, sorry, I should have a parentheses here, uv minus the integral of v du. Again, take the time to pull the numbers on the outside. So I'm going to pull this negative, or this 2 and this negative 1/3 on the outside with this negative, so that makes it a positive 2/3. And then I'm going to take this negative 2/3 and multiply it in, so I get a negative 4/9. Lots of multiplying. Okay, so now I'm looking at all of this multiplied out, and what do I have here? This is the question. This is what I'm trying to solve for. And so maybe if you need to see it, I can just rewrite it so you can see the order here. Okay, so let me just kind of make an aside. So what if I had this? If I had x equal a plus b minus 4/9 x, and I was trying to solve for x. What you would do is you would add 4/9 x to both sides, right? Add 4/9 x to both sides. So 4/9 x plus 1x would give me 13/9 x. Equaling a plus b, and then I would multiply by the reciprocal. Okay, so this is like my big X. So I have x is equal to a plus b, right? A plus b minus 4/9 x. So I'm going to add 4/9 of the integral to both sides. So add 4/9 of the integral to this side, it's gone. Add 4/9 of the integral to this side, it's a 1, but that's the same as saying 9 over 9. So I get 13/9 of the original integral equal to these two pieces that we're going to carry it along. Now I'm going to multiply both sides by 9 over 13, throw a plus c down, and it's done. Wow, that's a long problem. So I'm going to call this a wraparound, where you are predicting you're going to have to do parts twice, and then actually solve for the question by finding it in your answer again. All right, let's dig in. Let's do one. And you can decide to try it on your own. Again, let's just make sure we're always letting the u equal the e guy, and then we will come up with similar answers. So dv is dv is, something's beeping on me. Okay, dv is sine of 5x dx. Okay, so my du, I'm using chain rule, so I'm multiplying by the derivative of 1/4 x, so that'll be 1/4 e to the x over 4. Here I'm doing La Jolla theorem, so I'll get a negative 1/5 cosine of 5x. Okay, so let's put it together. So I need the original problem, so I'm going to carry it along. So I'll get uv, so negative e to the x over 4 over 5, minus the integral of v du. So I'll get negative 1 over 20. Okay, so we can take the time to pull the negative 1 over 20 on the outside. What am I doing here? E to the x over 4 over 5, cosine of 5x. So these come outside to be a positive 1 over 20. And then I'm going to do parts on this. So I'm going to start with u equaling e to the x over 4, dv equaling cosine of 5x, dx, du gives me a 1/4 e to the x over 4, dx, and my v will give me a 1/5 sine of 5x. All right, so let's put it in here. So, right, I'm doing parts on this. So I get uv e to the x over 4 over 5 times sine of 5x minus the integral of v du. So I get a 1 over 20 e to the x over 4 sine of 5x dx. Okay. Sorry, it got kind of squeezed in there. So let's take the time to fix it. So I get this original problem equaling negative e to the x over 4 over 5 times cosine of 5x. This times this, it's necessary to multiply this out. So I get 100. Okay, so I need to multiply this 1 over 20 times this negative 1 over 20, so I get a negative 1 over 400. Okay, so I've got it all written out neat. I'm expecting to see the question back in the answer again, and I do. Okay. So I'm going to add 1 over 400 of this integral to both sides. So I can get all of the integrals that I'm trying to solve for on the left-hand side. Okay, so that's a 1. So that's 400 over 400. So I get a 401 over 400 e to the x over 4 sine of 5x dx equaling these two first parts. Lots of writing. Keep nice and neat and organized. Now finally I can say e to the x over 4 sine of 5x dx is equal to 400 divided by 401. All of this carried along, sine of 5x plus c. There it is. So that's the antiderivative of that.